Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. So our chapter today is software testing strategies. So first questions, why do we need to have software testing strategies? So the answer is because we need to test the software. So what is the reason that you need to test your software? So software basically we test the software because we want to uncover errors that were made inadvertently as it was designed and constructed, meaning that you are trying to uncover the error, the mistake that you made, which is the mistake is you made it unintentionally and unknowingly, meaning you're trying to find what are the errors. Okay, so that is the reason why they use software tested. So by definition, software testing is a testing process of exercising a program with a specific intent to finding errors prior to delivery to the end user, meaning that you uncover errors before you start the deployment phases. Okay, because we want to release the product which is error-free to the users. And in order to test the software, the group of developer, the software engineering team, need to have software testing strategies. And for software testing strategies, who actually design the software testing strategies? And there are three parties, which are the project manager, number two, software engineers, and the third one is testing specialists. So these are the three parties involved in designing the software testing strategies. So when you test the software, what the results of the test will show? So that there are four, which is first, the result from the testing will show the errors. Second, requirement confirmance. The third one is the performance, and the fourth is the indication of quality. So what are errors? Errors actually mistakes in the codes. Okay, it's defects in any variance between actual and expected results. Errors is you made it unintentionally, unknowingly. So we have to find the errors. And then also the testing will show the requirement confirmance, meaning it's check the criteria to be fulfilled in implementation of a specification, meaning whatever you develop, whatever the software engineering team develop, meet the requirements as specified earlier by the user or by the customer. Then performance. Okay, performance actually shows the responsiveness and stability of the system that you have, or the software that you have under particular workload, meaning this system is reliable, working as it's supposed to work. Okay, for example, that you design a systems for students. So how many students are able to access the system at the same time? Okay, how big the size of the network will accept the data at the same time? So that is a workload. And indication of quality shows the functionality and the features. It should have the quality for functionality and also for the features. So for the software testing, we have a strategic approach. Okay, to perform effective testing, we need to have strategic approach, and that should conduct. You should conduct effective technical review. What is the effective technical reviews? Effective technical reviews is an effective mechanism finding mistakes early in the software processes, meaning it is go along with the process of the software development. Okay, and testing begins with component levels and work towards the integration. It starts from the smaller to the bigger to the larger. Different testing techniques are appropriate for different software engineering approach and different point in time. Yeah. Okay, let's see strategic approach. Also, second slide. Testing is conducted by developer of a software, and for large project, an independent test group, meaning the testing will be conducted by the developer and also independent test group. Okay, and you have to know that testing and debugging are two different activities. Okay, so let's see who actually do the testing. Who tests the software? So we have two parties, which is developer and also independent tester. Developer meaning part of the team member that develop the systems that they want to test. So the advantage is that the tester, the developer actually understand how the systems works. They don't have to study, they don't have to learn. However, there might possibility that the developer will test it gently and is driven by delivery. Okay, and there is a possibility of conflict of interest. Different from independent tester, which is this is not the one who involved in the development, so that this developer must learn how the system works. And what actually this tester do, they will try to break the systems and they are driven by quality. Okay, so these are the two different person that will test the software, two different group of person who just test the software. Okay, then another term in a software testing is verification and also validation. What is verification? What is validation? Verifications refer to the set of tasks that ensure that software correctly implements a specific function. Okay, while validation refers to a different set of tasks that ensure that the software has been built is traceable to the customer requirements. So there are two different things. Here. So to see it clearer, verification answering the question, are we built the product right? The second one, the validation, refer to are we built the right product? Okay, so let's see the strategy. We have see the approach. We have see who are the one who are going to test the software that we have. Now we are going to see the testing strategies. Okay, testing strategies. We have 4 here, which is start with unit testing. Okay, go to integration testings, and then validation testings and system testing. And each of this level of testing strategy, each of this layer actually tested different thing, which is unit test, it focus on the code itself. Integration test focus on the design. Okay, validation is focusing on the requirements test. System testing is on the system engineering. Okay, so these are the 4 strategies. A slide on the strategies, so you may see the slide later on. So this is the idea of testing strategies, which is start from the smaller, which is the code, to the design, which is referred to integration test, and to the higher order, which is the requirement. We start from small to the larger. All right. This is what I mean by we begin where testing is small and move toward the larger, meaning we start from the component and to the integration. So basically there are 2 kinds of software that we're going to test, which is the conventional software and also the object-oriented software. So what is the difference between both of these? Component software, actually the focus is on the module, as in the component. And the first task that we do is normally unit test. Then it moves to the integration test. It tests modules. Okay, but object-oriented is different because it focuses on a module. Okay, our focus when testing in the small changes from individual module to an object-oriented class, meaning the test actually refers to the class, the module in the classes, which is encompasses of attributes and operations and imply communication and collaborations of the classes. That is the 2 approach we will see. We'll see conventional software testing and object-oriented software testing. So strategic issues on testing, there are 8. Number 1, specify product requirements in a quantifiable manner long before the testing commences. So meaning that you have to make sure that whatever you want to test, before you start testing, the requirements is measurable. Okay, that is the first thing. Second, state testing objective explicitly. The objective must be clear. Number 3, understand the uses of the software and develop profile for each user category. In order to design and to develop the correct product for the correct user, you have to understand the user first. So then this is the 3rd criteria, the strategic issues of software testing strategies. Number 4, develop a testing plan that emphasizes rapid cycle testing. Build robust software that is designed to test itself. Use effective technical review as a filter prior to testing. Okay. Conduct technical review to assess the test strategy and test cases themselves. Develop a continuous improvement approach for the testing processes. So there are 8 strategy issues that you have to consider. Okay, so now we will see the unit testing. Okay, as I showed you earlier, we start from the smaller to the larger, which is start from the codes to the requirements, so that we will see each of the testing. Now we'll see each of the testing. So first testing we will see is the unit test, and then we'll do integration test. So let's see what is unit testing. This is the idea of unit testing. What you have here easily is a software engineer. Okay, so that software engineer has a module, and the module that designed or written need to be tested. And how to test is using test cases, so that you will see the results, which the output will be the 4 output that I told you earlier, like error, okay, the conformance, the performance, okay, and the quality too. So the result will be the 4. So software engineering, they have the module to be tested. How to test it using test cases. So you may identify error, you may identify the performance, you may identify the quality letter. So what actually the test cases do is that these are the 5 items that is tested using test cases. Interfaces, local data structure, boundary condition, independent path, and error handling. All right. So unit test environment, we use stub. I will explain what is stub later on. We use driver, we use stub. Okay, I will explain what actually stub later. So how it's work? Okay, let's see. Okay, this is example of unit test. Okay, so what you have here is that a production code, meaning this is the actual code that written. The working code. One, this working code is for basic math, meaning this code is to do calculation, to add, to subtract, to divide, to multiply. When we say this unit test, meaning it will test the code. How it tests the code? These test cases need to be developed, need to be designed to check whether whatever is developed in this production code is correct, to identify error, to make sure that it pass and return the correct value. So that is unit test. Okay, so this is how it works. So you have the module. How to test a module? You have to write the test cases. We call it unit test cases. Run the unit test cases and see if there is any errors, if there are any performance issues, and so on. So that this is the one that you normally test using unit test case. All right. Okay, so let's see what is this. All right, basically this image shows how, okay, the railway trail should align so that it is functioning. Okay, so that is the idea of integration test, meaning you have modules and how to make sure that the modules are integrated to each other. Okay, the idea of integration testing is like this. Let's see, you have modules. So in a project, normally you have many modules, and that modules is developed separately, and how to make sure that each module may talk to each other, so that we do integration tests in order to do it. So we have one module, we have second module, and we have integration tests to check to see how actually it may talk to each other. So integration testing basically is a systematic strategy constructing a software architecture and test to uncover errors associated to interfacing. Again, is there any errors when two modules are going to talk to each other? Okay, that is integration test. So I want to explain to you what is stub and driver first. Okay, basically stub and drivers both are dummy codes. The difference is that stubs is used in top-down integration, okay, while driver is actually used in bottom-up integration test. So stubs, the purpose is that to allow testing the upper level of the code when the lower level of the code are not yet developed, meaning you have two modules, upper and lower, module A and module B. So module A need to communicate with the module B, however module B is not developed. So we replace the module B with stubs. And while driver actually is allow testing of a lower level of the code when the upper level of the code is not yet developed. This is contradict. This is different from stubs. Okay, let's see. Top-down integration, it use stubs because stubs actually meant for top-down integration. Does the meaning is that top model is tested with a stub. Okay, because B is not ready, so B will be stub. Okay, so this is top down integration test, meaning it starts from the top module, okay, to the next level of module, to the until you see the final one. Okay, so let's see how it works. Okay, top down integration test, we have two approach, which is top down testing with depth first, top down testing with breadth first. Okay, how about depth first? Meaning you test the first module, followed by second module, and then M5, and then M8. So from top straight away to the bottom. Okay, and then we have M1, M2, M5, M6, M8, and we have M6. Meaning you have to test M1, M2, M6, but we don't have to repeat M1, M2. It is M6 straight away. Okay. However, top down with breadth is different. It starts from the lower module, which is M5, M8, M5, M6, M7, M2, M3, and 4, and then straight away to M1. Okay, so that is from top down, meaning from top to the bottom. Okay, integration test. Then you have also bottom up integration. This is contradict. This is different with the top bottom. So bottom up meaning from the lower part of the system, the module, and then go to the upper level. So this is bottom up, meaning we start from the below. Okay, worker modules are grouped into builds and integrated. This is a cluster. We call it as a build, and then we go move forward, upward. Okay, how it's been done? Okay, this is how it's been done. First, we have identified what is the lowest module that you see here. What is the bottom module, which is E, F, and G. So we have E, F, G, and don't forget C. Okay, how to test it? Meaning we have to group the test in the form of cluster. We call it as a build. So that one build consists of E, F, and also B. Another one consists of D and G. D and G. Okay, another one C. C here is alone, meaning C has to be tested with A. Once you test it with A, we tested all. Okay, so that is from bottom-up integration. Then we also have sandwich testing. Sandwich testing basically is a combination of both top down and bottom up. Okay. Okay, sandwich testing is a type of testing that consists of two parts. They are top down approach and also bottom up approach. This is how it looks like. Top down, bottom up, and we call it also hybrid, which is we call it a sandwich testing. So this is how it looks like. You see that it tests from A here and also tests from the bottom, which is E, F, and also G. Okay, so that's how it's work. Bottom. We test from top to bottom and bottom from up. Bottom to up. Okay, so then we will see the regression testing. Okay, basically what is regression testing? Regression testing is a process of testing changes to computer program to make sure that the older program will work with the new changes, meaning you have existing system, but you do some changes, and now how to make sure that the new changes work with the old one. Okay, that is regression test. Regression testing is the re-execution of some subset of tests. Okay, you do not test everything. It's subset of tests that have already been conducted to ensure that changes will have not propagate unintended side effects. Okay? So whenever software is corrected, some aspect of the software configuration, such as the program, the documentation, and the data that support it is changed. Okay? So then you do regression testing. So regression testing helps to ensure that changes do not introduce unintended behavior and or additional errors. Okay? So regression testing may be conducted manually by executing a subset of all test cases or using automated capture playback tools. So this is just a cartoon of regression tests. You see that you are opening for new things. Okay, you are trying to avoid errors. Suddenly, when you do enhancements, improvement, they actually you introduce more bugs and errors in the system. This is something that we don't want. Okay, all right. Then we have another type of testing, which is smoke testing. What is smoke testing? Okay, it is a common approach for creating daily builds for product software. Steps of smoke testing. Software components that have been translated into code are integrated into build. The one that I mentioned earlier, something that you see consists of cluster of module. Okay, a build includes all data files, library, reusable modules, and engineered components that are required to implement one or more product function. It is a cluster basically. Okay, of the data files, of the libraries, of modules. Okay, that required to implement one or more product function. Then second steps, a series of tests is designed to expose error that will keep the build from properly performing its function, meaning the combinations of the group of libraries and data file, actually you try to expose the error, whether they can work together or they cannot work together. Then the build is integrated with other builds that the entire product okay, is smoke tested daily, meaning each of the function which is consists of build, meaning that will be tested daily. We call it as a smoke testing. All right. So smoke testing build is a version of application which is still under testing. It may be seen as bundle integration of programming code in an executable format, which is passed over the testing team in order to evaluate the corresponding functionality of the software under development. Okay. In simple words, build is a piece of software application developed from integration of executable code and is accountable for a particular features and functionality of a software product. So that is smoke testing. All right, so let's see. This is an example of smoke testing, meaning you have build 1, build 2, build 3, a group of files, libraries, modules, which actually lead to one function. So when we test it, we do call it as build smoke test. If smoke test pass, and then we may do the following test. If not, meaning it is the build rejected, and then the software engineering has to do some amendment and some correction, okay, or debugging. All right. So then, general testing criteria. So what is general testing criteria? For all of the tested, interface integrity. Okay, we have to do functional validity. We have to do information content. We have to do performance. Okay, so these are the things that we do. All right. So let's see to the next testing, which is object-oriented. Okay, object-oriented is a collection of testing techniques to verify and validate object-oriented software. Again, verify, validate. Previously, we also have seen the verify and validate. Are we building the product right? Are we building the right products? So that's the questions. So for object-oriented testing, begins by evaluating the correctness and consistency of the analysis and design model. Testing strategy changes. Okay, the concept of unit broadened due to encapsulation. Integration focus on classes and their execution across a thread on the context of usage scenario. So validation uses conventional black box methods. Test case draws the conventional method but also encompass special features. Okay, let's see. Testing the CRC models. So CRC models, we have to revisit the CRC models and object-oriented relationship models, inspect the description of each CRC index cards to determine if a delegate's responsibility is part of collaborator definition, invert the connection to ensure that each collaborator that is asked for service receiving requests from a reasonable source. Using inverted connection, examine step in step 3, determine whether all the classes might be required or whether responsibilities are properly grouped among the classes. Okay. Determine whether widely requested responsibilities might be combined into a single responsibility. And step 1 to 5 are applied iteratively to each class and through each evaluation of the analysis model. So this is, if we test using OO, we have to test the CRC model. So basically what we have to do with that. All right. So in order to do object-oriented testing, we have the testing strategy. So first is class testing, second is integration. Class testing is equivalent to unit testing, meaning operations within the class are tested. The behavior of the class is examined, meaning how actually it interacts. Then integration, applied 3 different stages, like you see integration in conventionals, so that the first is thread-based testing, second is use-based testing, third is cluster-based testing. So what is thread-based testing? It's integrate set of the classes required to respond to input or event. Set of classes required to respond to in one input or event. That is thread-based testing. And use-based testing integrates set of classes required to respond to one use case, meaning what actually the one use case. For example, user, or what user will do. Okay, so cluster testing integrate the set of classes required to demonstrate one collaboration. That is cluster, meaning let's say if you have classes, we have to talk to other, which has to collaborate with each other. So we do cluster testing. All right. So web app testing 1. Okay. Web app, we call it web application because this application is for the webs. So that the content of the model for web app reviewed to uncover error. Okay, when you have web application, what you have to do, meaning the content model for web app is reviewed to uncover errors. The interface model is reviewed, okay, to ensure that all use cases are accommodated. The design model for the web is reviewed to uncover navigation error. Again, when we talk about web app, it has navigation error. When you click certain link, it go to which page and so on. The user interface is tested to uncover errors in presentation or navigation mechanics. Okay, then each functional component is unit tested. So for web app also we do this kind of testing. Then web app also we navigate throughout the architecture is navigated. Okay, meaning navigation throughout the architecture is the whole system stuff. The web app is implemented in variety of different environment configuration and is tested for compatibility with each configuration. Security tests are conducted in attempt to exploit vulnerable in the web app or within its environment. See, security checks also being conducted. Performance tests are conducted. This is important for web app testing. The web app is tested by a controlled and monitored population of end user. Okay, you cannot conduct the test for all people. You have to select. The results of their interaction with the system are evaluated for the content navigation error, okay, usability concern, compatibility concern, and web app reliability and performance. So these are what actually evaluated for web app testing. Then we have also mobile apps testing. Just now it was web-based web apps. Now mobile apps testing. So everyone using mobile applications such as like your WhatsApp. So what actually tested is user experience, device compatibility testing, performance testing, connectivity testing, security testing, testing in the wild, okay, and certification of testing. Okay, Testing in the environment meaning you test the app on user devices in actual environment. That's what does it mean by testing in the wild. Okay, so higher order testing. So higher order testing, this is the testing for the higher level. After you do component, after you do integration, we have higher order testing. So basically what need to be done is validation testing, okay, system testing, alpha beta testing. Alpha beta testing basically focus on the customer usage, meaning user actually use the systems that you develop, they use it and you get feedback from them. And then recovery testing, okay, security testing. Security testing is verifying the function of mechanisms built into system, and actually is to protect from improper penetration. Okay, and then stress testing. Okay, this is actually to execute or to check for the manner of demands resources in abnormal quantity, frequency or volume, how many user the system can support, for example, the maximum number. And the performance test, this is about runtime of software within the context of integrated system. Okay, so that as I told you earlier, debugging and testing is different. Debugging is a diagnostic process. You finding and correcting existing and potential error. That's what does it mean. Meaning you do it when you're coding. Okay, so that for debugging process, there are 4 stages that you have to follow. First, you locate the error. You design error to repair, and then you repair the error, and then you retest. So this is what debug. Okay, debug is all about. So debugging effort required time to correct the error and conduct regression tests, and also required time to diagnose, okay, to determine the cause and system. Okay, those are the debugging effort that you need to spend time on. Okay, system and cost. System and cost could be system and cost may be geographically separated. Okay, symptoms may disappear when another problem is fixed. Okay, cost may be due to combination of non-error. Cost may be due to system or compilation error. Cost may be due to assumption of everyone belief. Cost symptom might be intermittent. Okay, meaning these are the system and causes that problem that we faced in our project, in our course. Okay? All right, so consequences of bugs. Okay, bugs category is function related bugs, system related bugs, data bug, coding bugs. So there are many types of bugs. So this is the bug type and the damage it done. Okay, so mild bug, not much. Okay, normally at the mild bug it's at early stage, but if it's a catastrophic, it will have a lot damage. It will damage a lot on your systems of your system. Meaning more bugs, meaning your system will be more complex. More complex meaning it is hardly to maintain. Okay, so debugging technique, we have brute force or testing, we have backtracking, we have induction, we have deduction. These are the techniques for debugging. Okay, and also we do correcting the error. Okay, so there are questions that you have to answer. Is the cause of the bug reproduced in another part of the program? Okay, what next bug might be introduced by the fix I'm about to make? Okay, what could we have done to prevent this bug in the first place? So you may see and you may read what you should do. Okay, all right. That's all for this topic. So you have to think before you act to correct, because perhaps you introduce more problems to your systems. Use tools to gain additional insights. Okay, there are many tools assist in testing. If you are not imposed, get help from someone else. Okay, then once you correct the bug, use regression testing to uncover any side effects. Okay, we don't want to do correction of bugs. Instead of we do correction, we introduce more bugs to the system. Okay, thank you.